Hi. I hate being on camera if you didn't know. It's really hard for me, you guys, but I'm getting used to it. Okay, so I kind of wanted to go over lesson 25 test questions that everybody got wrong. I just threw out the questions, but I did want to go over how to solve the problem so you guys know. So it was number 2 and number 5. I'm going to go through it and hopefully you guys will learn something from it. That's what I'm hoping. Okay, so number 2 we'll start with. It says, we're in lesson 25 test. Francine read that when iron 3 nitrate was mixed with lithium hydroxide, iron 3 hydroxide and lithium nitrate were produced. If Francine needed to prepare 13 moles of iron 3 hydroxide, how many grams of lithium hydroxide would she need? So first we're going to write out our reaction. Okay, so we've got iron 3, so it's a positively charged 3 nitrate. That has a charge of -1, okay? And then we're adding lithium hydroxide, okay? And iron 3 hydroxide plus lithium nitrate. Okay, so we have to balance the equation, and the way that we balance it, I'm not going to go through all the steps because you guys know how to balance. We put the 3 in front of there and the 3 in front of here, and we are balanced, okay? So we know that we need to prepare 13 moles of iron 3 hydroxide, okay? Based on the mole ratio, she will need, how many grams of lithium hydroxide do we need? Okay, so we know right now mole ratio is 3:1. Okay, that's first step, we're done there. Okay. It's pretty simple. So if we need 13 moles of that, we need 3 times as many moles of lithium hydroxide to make 13 moles. Do you see what I'm saying? For every 3 lithium hydroxide, we make 1 iron hydroxide, okay? So all I'm going to do is take 13 times 3. And that's how many moles of lithium hydroxide we need. We need 39 moles, okay? So that's one part of the question. Now, all we need to do is figure out what the molecular weight is of lithium hydroxide and multiply that by the amount of moles that are needed. So lithium hydroxide weighs 24 grams per mole. So we just multiply that by 39 moles, and your answer is 936 grams are needed to make 13 moles of iron hydroxide. So I'm not sure how this went wrong, but hopefully that helps you guys. And then I'm going to do number 5. So number 5 says when barium chloride is mixed with potassium bromide, potassium chloride, barium, and bromine gas are produced. Okay, so let's just write the chemical equation out. So we've got barium chloride. So potassium bromide yields potassium chloride plus barium plus bromine gas. Okay, so we need to balance this equation, and I'm just gonna skip over that. I've already done the work. That's balanced now. Okay, let's move to the next step of the problem. You've been asked to prepare 500 grams of potassium chloride. Okay, from this reaction. Will you have enough barium chloride if your stock container says that you have 500 grams available? So there will be conversion of grams to moles here. But first, these are the molecules in question. Our mole ratio is 1 to 2. Okay. So the next step is figuring out, first of all, let's figure out how many moles this is, okay? So potassium chloride weighs 74 grams per mole, okay? And it says we need to make 500 grams. So let's figure out how many moles we have if we have 500 grams. So you just take 500 grams divided by 74 grams per mole. And that means we have 6.7 moles of KCl. Okay? So if we have 6.7 moles of KCl, how many moles of barium chloride do we need to make 6.7 moles of KCl? Well, if the mole ratio is 1 to 2, that means we can divide it by 2. And that means that we only need 3.35 moles of barium chloride to make 6.7 moles of potassium chloride, okay? So we need 3.35 moles of barium chloride, okay? So do we have 3.35 moles of barium chloride here? The only way to know is to figure out how many moles we have if we have 500 grams, okay? So barium chloride has a formula weight of 207 grams per mole, okay? That's how much this weighs. So we have 500 grams. We're gonna divide it by 207 grams. And that means we have let's see. I need a calculator. Do you have a calculator, Ryan?
Mm-hmm.
Thank you. Okay. So 500. I don't know why I didn't write this down. Okay. Oh, I did write it down. Okay. That means we only have 2.42 moles of this barium chloride, but we need 3.35 moles, right? And that's pretty much it. So we do not have enough barium chloride if we only have 500 grams to make 500 grams of potassium chloride. So I know there's a lot of steps in there, but hopefully that makes it a little bit clearer for you guys, okay? So that's all I had to say. I didn't count it in your grade, but I think it's good to see where you went wrong always, because that'll help you further down on the road, okay? Thank you.